Okay, let's get started. So we entered this sort of last segment of today's talks, and we have Dana Robinson, who is the Director of Software Engineering at the HDF Group, and he'll tell you something about the state of HDF, HDF5, that is.
Do you want me to do the two talks together? I can just put them back to back. Yeah, so I have two talks. There was one supposed to be yesterday, and then there's one today. Today is supposed to be about community building. Yesterday was more the state of HDF5. So in the interest of time, I'm going to put those two together, and we'll try to go through them pretty quickly. So let's hear. So upcoming features for this part is going to, we'll talk about the upcoming features. Oh yeah. That's the secret.
The secret. Can you hold this? I think we have to join and share. And we have to share a window. And we want to share on this one, I think.
Yep. Okay. Okay. So you guys can see that now? Okay. So we'll talk a little bit about the release schedule and kind of what's up with HDF5 in the future. Now, I'm not going to have a lot of time to go through all the upcoming features in any great detail. That would take a talk twice as long as I even had scheduled for. But we'll just briefly talk about them. You can find the RFCs for them on the individual the feature branches where they reside. So the Onion VFD is basically about versioning HDF5 files. Requires an external Onion file for everything outside of the first one that you write. And then the version info could be stored in the original file, but we decided to not do that, and so now we have this external Onion file that stores all your subsequent versions of it. And you can check out different versions. When you open the file, you open up version 3, and you see the state of the file at open. And by versioning, we mean between opening a file and closing it. That's a version. And so this is integrated with the command line tools. You can ask h5dump to give you a specific version of the file, and so on. This is in feature Onion VFD branch in the GitHub repository, and this will be released in HDF5 1.13.2. And we're going to have a demonstration of this by one of our developers in a little bit. VFD Swimmer is coming out soon. This is basically Swimmer 2.0. We refer to the older version of Swimmer now as Legacy Swimmer. The older version that was released in 1.10.0 uses flush dependencies to basically make sure that you always see a consistent version of the file. This one's different. This is an external metadata snapshot file instead of the flush dependencies, where metadata pages have an index, and it's the users are smart enough to get the data from the metadata file when they're required. This allows most operations, including object creation, so you don't have to do that trick anymore where you create all your data sets and groups and such, and then close them, and then start doing the Swimmer stuff. This supports general HDF5 operations. We're leaving Legacy Swimmer in place for now, so we're not deprecating that at this time. And it'll eventually work with network file systems like NFS and SMB, which does not work with Legacy Swimmer due to issues with POSIX file semantics. So this is in the feature VFD Swimmer branch in the HDF5 GitHub repository. The documentation for most of these features that we're looking at today is doc directory. There's an RFC inside of it that describes them in both PDF and doc. And again, this will be released in 1.13.2. We also have features selection IO extends the VFD layer so that IO operations can pass vectors of reads and writes instead of just single ones. It allows the creation of more complicated derived MPI types instead of breaking complex IO into multiple read and write calls. It's mainly for parallel HDF5, but has applications for other things like for the S3 VFD, which has not been updated for this. This is already in the develop branch, and this will be released in HDF5 1.13.2. We also have a feature called subfiling, which is currently under active development. It's basically IO concentrators for parallel HDF5. It's a middle ground between file per process and single shared file. Lets the user make the trade-off between the number of files you have open and lock contention in your parallel file system. It's implemented at the VFD layer. It had a couple different iterations over the years, but where it lives now is in the VFD layer. And it is in the feature subfiling branch in the HDF5 GitHub repository. And it'll be released in HDF5 1.13.3. We have another feature that's coming out this year. It's multi-dataset IO. It spreads IO among multiple datasets in parallel HDF5, minimizes the number of IO calls when writing to multiple open datasets concurrently, limited to datasets stored in a single file at this time. And this is in the feature multi-dataset branch in the HDF5 GitHub repository, and this will be released in HDF5 1.13.3. We also have another feature for anybody who is interested in the virtual object layer. We're going to be adding in API Compatibility Flags over the summer. This will allow a virtual object layer connector to specify which aspects of the HDF5 API it supports, because when you create a virtual object layer connector, a lot of times people don't implement the full suite of HDF5 API functionality. In fact, the native Vol connector does not even support all the possible operations, because we don't support maps in the native file format. So, this will also work with the Vol test repository to provide better testing. And there's no set release date right now. I expect this will probably come out in 1.13.3. And we'll talk about where when these versions will be released in just a minute. And if you want to be a part of this, if you are interested in Vol development, then let me know, send me some email, because we're going to be trying to finalize the set of feature flags that we use to specify what aspects of the API you can specify that you support or do not support. Because it's not just as easy as, like, I support these certain API calls. It's about other things too, like creation order and things like that. So it's more complicated than just which API calls do I support. So releases. So we have a release schedule that we now put on GitHub. It's in the readme.md file, so whenever you go there, you can see this, and we will keep this current. In fact, what we're looking at right here was just updated by me. I don't think it's even up on the official GitHub yet. This is all super brand new. You can see the different versions that we have on here. We have 1.8, we have 1.10, we have 1.12, we have 1.13. I backed it up to 2021, so you can see where the previous versions were, and I have it forecasted out until 2023. And I'll slide this window along as time goes on. So one thing that we should talk about is experimental versus maintenance branches. This is the thing that we introduced last year. It's the maintenance branches are the even-numbered minor releases. So 1.8, 1.10, 1.12, soon to be 1.14. Those are the usual HDF5 maintenance branches that you all know and love, that we maintain binary compatibility across versions of it. 1.12.1, 1.12.2, 1.12.3 all have binary compatibility. Stable file format. We don't change things very much in those branches. We add things sometimes, but we're not going to change the binary compatibility. The odd-numbered minor releases are experimental releases, and this was introduced to better support ECP, get features out to users in a released version that they could then test and experiment with and not have to check out the code and build it and things like that. There's no binary compatibility guarantees. API calls can change. API calls can disappear. The file format can change. It's really designed so that people can test out these new features and give us feedback on them. So if you have software that's production software, you probably should not be using an experimental release for that. There's a blog post for this for more clarity. So HDF5 1.8. HDF5 1.8.23 will be released at the end of the year, and I intend for that to be the last version of HDF5 1.8. We've been carrying that version for a very long time, and it needs to be dropped. The main thing that's keeping it alive is performance issues, which should be addressed this summer. I'll show some graphs of what we see from the performance. It's not perfect, but it's an indication that we're getting close to where we can get rid of it. HDF5 1.10, HDF5 1.10.9 was just released a few days ago. Depending on the summer's performance gains, we may have a fall release of HDF5 1.10, so 1.10.10. And this will most certainly live on into 2023, because I assume that people are not going to be in a big hurry to jump on a brand new maintenance release that we just pushed out the door. So we'll leave that alive for a little while, and then we'll retire it at the end of 2023, early 2024, depending on people's experiences with 1.10.14. HDF5 1.12, that was just the last version. 1.12.2 was just released in April. HDF5 1.12.3 will be the last release of the HDF5 1.12 maintenance branch. That'll probably be early in the new year, could be at the end of this year, but I'm assuming we'll leave it until January, February. The reason that we're retiring HDF5 1.12 so quickly is that it has an incompatible Vol layer. As we developed the pass-through Vol connectors, it became apparent that we needed more functionality and required expanding the Vol struct, the Vol class struct, to have different callbacks and extra fields in it. And so since that breaks binary compatibility, we couldn't push those changes back to HDF5 1.12. And so once 114 releases, there's really no reason for it to be around. It's essentially develop the 113 branches without the fancy new features and with a broken old version of the Volt connector. So also, if you are working on Volt connector stuff, you should be using develop and targeting 113 and not 112 because there are changes there, especially if you're doing a pass-through connector. So HDF5, 113, 114. 113.2 is to be released in July. Currently, the website says that it's June, but the Onion VFD and VFD Swimmer required a little bit more time to do the integration work. So we're going to be doing code reviews of those in the next month. And so it'll be July before those get out the door. Selection IO, as I said, is already in the develop branch, so that's all ready to go. 113.3 will be released in September. That'll have multi-dataset IO in it and subfiling. And then 114.0 is going to be released in November or December. Right now on the schedule, it says December. I don't want to ruin Christmas, so I'm going to try to do that at the end of November. My target is to have it out the door before Thanksgiving. And then 116. So after the 114.0 releases, develop will switch to 115. And it's not clear if the next version is going to be 116.0 or 2.0. I'm in favor of doing 2.0. Considering it a bigger change, we'll finally start doing semantic versioning correctly. We'll drop some of the deprecated stuff that we've been carrying for a long time. With the Volt connectors, it started to get kind of silly, and the H5O calls, where there's like version 3 of API calls now. So we should drop some of that stuff and remove some of the deprecated things. There's some other things that I've mentioned on here, like condensing the metadata categories and the multi-VFD to split VFD, making other VFD changes. One of the things I'd like to do in like an HDF5 2.0 is to really spend some time to address long-standing technical debt, like Windows Unicode, thread safety issues, which we can do in partnership with the Lifeboat and the contributions that they make. Hardening the reading the file and putting things into the cache code, which is where a lot of our CVE issues come in as we decode metadata that we've read off the disk. A lot of internal refactoring. As Elena mentioned, it's a 25-year-old code base. It is old. It has a lot of creaky stuff in it that made it was a good idea back in 1997. And it's just not a very good idea now. And we've done a lot of work to keep this up to date, to keep it in good shape. But still, there's a lot more refactoring that I think needs to be done. And things like variable length data improvements, like that's been a thorn on our side for forever. And so with our HDF5, so the next 2 years, 2022 is mostly going to be about getting these largely for ECP features out the door and into the library. There's a lot of releases that have to take place this year. We've already gone through a bunch of them. There's still several active in development features that we have to finish up and get into the library. So that's going to be a big challenge. So we're not going to have a lot of time to do other things in the library this year, I don't think. With one exception, and that is the performance improvements that I think that we need to make. We're very close, I feel, and we want to get that done so that people are more comfortable moving from 1.8 to 1.10. And we need to drop several of these maintenance branches because doing the releases for these is not just as simple as tagging something in GitHub and saying now this is HDF5, 113.3. There's an extensive testing process, and the maintenance for this is just killing us. So we have to drop a lot of these maintenance branches because it's too many. The other thing that I want to work on this year is community engagement and participation. I have a whole other talk about that I'm going to get to as soon as this one is done. But in 2023, that's where I think we're going to spend a lot of our time trying to make HDF5 a more maintainable piece of software moving forward. And I'm very interested in discussing this with anybody who wants to talk about this. And this will also be the topic of my next talk. We'll talk about that. And I view that as like HDF5 2.0, where this is where we start to really make more of a break with the legacy piece of code that is HDF5 right now. Not in a way that you have to worry that you're going to lose backward compatibility with old files, but just the software really needs to be updated for modern ideas about how software is supposed to look. So performance. So there was a significant performance regression between 1.8 and 1.10. Several fixes have brought 1.10 closer to 1.8 levels, but there's still some differences between those two, and we'll look at those in just a sec. This is really critical work. There's many people who have told us that that performance is what's keeping them from updating to 1.10, and it's causing us to carry this legacy piece of software for forever. Although I will say I think that a lot of people tested it right after 1.10 came out and have not checked it lately because it has gotten significantly better, as I will show. So So here, this is from Grafana. There's a link on the bottom so you can go look at it. The username and password is like demo. Whoop. There we go. Like that. Okay. So the username and password is demo and demo because we take security very seriously at the HDF group. So you can see here, there's this, the yellow graph at the bottom here is the 1.8 performance. And there's a lot of jitter here because this is run on a machine at the HDF group, which has varying load and stuff like that. Then this here is 110 when it first came out. And you can see behind it here, this is 111, which at the time was the develop branch. So these were basically the same thing. So as they went along here, we had this part where we realized we had a huge performance problem, and we fixed a large chunk of it several years ago with this. This is the context changes, where we added these API context things in, so where we stash values as soon as we come into the API, and then we just retrieve them out of this context object when we get to the place where they're used, which is usually like the I/O calls and places like that. And then the rest of this down here is still noise. Is mostly just noise. We still have this gap, and that's the gap that I want to close. On Grafana, the titles here are not particularly helpful. I'm trying to rework how this is presented to people to have more helpful context so people can see what things are slow and what has improved. And right now, it's really a work in progress. But this is like a two-dimensional, unlimited in 2 dimensions data set where you're appending to X and Y, if I remember correctly. Then, so here is where not only do we have this big improvement here where we introduce the context stuff, but then we also have this bit down here where this is there were some small improvements made to the metadata cache where there's a skip list of things that we have to concoct to flush stuff out to the disk, and now we lazily construct this instead of maintaining it. And so just sometimes these small little things like that are the difference between good performance and bad performance, and that's what we're going to do this summer. Is I'm going to pull engineers and we are going to sit down and we are going to fix this because it has been driving us bananas for years. But there's areas where we do well, and that's also important for people to understand. That people hear this comment that like, oh, 1.8 is faster than 110, and so we can't move to it. Well, this is 1.8. All these graphs here, these are all in seconds, like wall clock seconds to run programs. So higher is worse. And this is 1.8, and everything else is faster. And that's because it's a 2-dimensional data set, but it's unlimited only in one direction. So when you're appending to this, the chunking index that you're getting for this is the newer extensible arrays that were added in 110, and these are significantly faster than what we used to use when this was a version 1B tree in 1.8. So it's not always that 110 is going to be slower than 1.8. And here's another example. This is making selection out of large hyperslabs and stuff like that. And here you can see this big circle here. This is where we introduced a bunch of changes to make the hyperslabs faster, just a whole bunch of hyperslab performance improvements. And then this orange line here, this is 110 when this got merged into there. And this is a huge change in performance for certain workflows. So again, you should really check to see if this is still true if you're worried about migrating to 110 out of 1.8. So, and also, since we're going to be doing this work over the summer, if you have a use case where you see poor performance, then please contact me and try to make a C reproducer that I can profile and test and see what the problem is so that we can fix this, because this is a very high priority for me over the summer. So one of the things that I also want to mention today is funding sustainable engineering, because we have a difficult time finding resources to just do the day-to-day maintenance of the library. This has been a long-standing problem with the HDF group for many, many years. There's no pile of money to perform a lot of maintenance. We get money from certain government agencies to pay for features, to pay for certain aspects of maintenance, things like releases and certain testing. But for adding like things like performance improvements, the money for that is just not necessarily there. And so it's addressing a lot of these like maintainability issues like code quality and just fixing things like warnings and making sure that compilers are up to date and stuff like that. A lot of that has been a labor of love by a small number of HDF group staff. And so this has been a big challenge for the HDF group for many years. So yeah, I do want to, when people want us to add features to it, just please understand that like it is really difficult for us to do this when it's an unfunded mandate, because there are no extra developers. Like for me to implement anything, for me to fix any bug, to look into any problem, to address anything, requires pulling me from funded work that keeps the lights on. So how do we make HDF5 a more sustainable piece of software? And this is kind of what I'll talk about in my next talk. And that is, I think one is more maintainable code, is that the library has grown a lot over the 25 years of its existence. And so we really need to go through and take time to go through and reduce, refactor, simplify. Another thing that we're lacking is we lack a lot of internal documentation. And so that's another thing that is going to be a big priority for us over the next year or two, is to create documentation, not just, I mean, for internal documentation stuff like at a deeper level, but also at like architectural documents, the kind of things that people who want to contribute to HDF5 need to understand, contributors guides of all types, and to automate more stuff, to move more to more continuous integration, continuous deployment. And so we'll have more of this in the talk that I am just about to give. So I'll pause here. We can do some questions if people have questions, and then I'll move on to the next one.
Okay, now, so maybe rather a comment than a question regarding the funding. So just like from the other side of things, it's even harder, I guess, in my other field to persuade like business customers that we need to, do this maintenance kind of work if it doesn't bring them any value, right? So then what we try to do is we are open with that, unless you maintain the house, one day it will fall upon your head, right? So then we say, okay, if you are implementing new features, let's say, then let's add for the next half a year, like 20% extra to each feature. And hopefully if we can, make the roadmap in the way that we will be actually refactoring the same module as the feature is on, then it will be even more efficient, right? So is this the kind of approach that you are taking, or?
I think and maybe Garrett or can talk more to this. I think it's difficult for us to do that on federal contracts, because the federal government contracts you to create a thing and you can't write a lot of profit into it above like some certain baseline level. I think it's very difficult for us to write. That has to be kind of explicitly written into the contract, and I don't know how well that works.
Right, but we are talking about HDF, not federal contracts.
Yeah.
Yeah, no, it's basically right. We can't, it's not easy for us to just write that in there and then some bureaucrat just nods and says, yeah, it's for a good cause. It's not that simple.
Yeah, it's challenging because we don't sell anything. We're an open source, not for profit, so we don't have like an HDF5. People don't buy it, aside from things like support contracts and stuff like that.
There was another question.
Yes, thanks for the talk and the status of HDF5. Yeah, and I wish you good luck for the funding, because it's very hard to sell maintenance to people, even to management. So everyone wants new things, while you need time to make things that continue working. So I hope you succeed in that. I have a more specific question on the new swimmer mode, which is something that we will be eager to use. Is there some limitations to foresee in the usage, like through NFS or GPFS from different computers, or other limitations?
There's some plans in place to have it. There's an auxiliary process that we started work on that is not entirely finished that will allow you to use it over NFS. It's always been a limitation of Swimmer. And then there's some other things that, if I remember the last status I remember, there's still problems with things like variable length data, because variable length data is a little weird. But there may be other places where it's still a feature that's under development.
Yeah. So. Okay, thank you.
Okay, other questions? There's a question online, I think.
Yes. Hello, this is Ulrich. Ulrich Pedersen from Diamond Light Source. I'm also interested in the Swimmer 2. I have to admit that I have not been following on what you've been up to in that, and I was just wondering, we've started to run in. We've used Swimmer for many years here at Diamond, and we've started to run into this point where data rates, or rather our detectors acquisition rates, have gone up so much that we're starting to hit sort of bottlenecks in performance, because we're simply just doing too many reads and writes per second, and it's starting to I'm guessing it's starting to sort of have an impact on our GPFS metadata service. I just wonder if that new Swimmer version could, well, I would hope that it will be more performant in some ways. You're saying you're moving the metadata out of the HDF5 file and into a separate file, is that right?
It's not permanently in a separate file. It's just when it's open, it creates a metadata, like an external metadata cache file, and then that is where the reader can get certain pages of metadata. So everything's set up by pages, so you kind of reduce the number of I/O you have to do, the amount of I/O you have to do. So you may want to. We just did a beta release of VFD Swimmer, so you can try that out and then let us know. It has not been extensively profiled for performance.
Right. Okay.
So
yeah, that'd be very interesting.
We would appreciate any improvements you can create on that.
Right. Thank you.
Any other questions for now?
Hi.
Okay,
yes.
There's one more. Go ahead.
Okay. Hi, Dana. This is Lucas. So I have a question regarding the new onion feature. So besides freezing the data, do you also keep a copy of the metadata at the time that a new version arrived? I'm mostly thinking about the fact that you may have filters that may produce different values. So I don't know if you are envisioning a mechanism to capture the version of a given filter that the data was using at the time it was frozen?
I couldn't understand that. It was a little hard to hear.
Okay, can you hear me better now?
Yeah.
Okay, so
Yes.
my question was regarding the new onion feature. So besides freezing the data, when you create a new version of that data, do you also create a copy of the metadata? I'm mostly interested to know about the fact that I'm mostly interested to know if you are storing information regarding the version of the filters that were used on each, a snapshot of the data, because filters may have bugs, and depending on which version of the filter you're running, it may produce different.
The metadata goes into the onion. Yes, the metadata goes into the onion file, and so that has things in it like the filters and stuff like that, because your filter pipeline is stored in the dataset's metadata.
Oh, cool. Yeah. Okay, good to know. Thank you.
Yeah. All right.
Andy has a question.
Sure.
It was slightly related to what this last question. I mentioned yesterday this problem of concurrent access. Could the onion file be used to have looking at a slightly older version of the onion VFD? You could have a copy of the file which is readable. So. Yeah.
Well, I think you'd just be moving your problem to having concurrency issues with the onion file, trying to figure out which version you're going to open and things like that. And there's only one onion file total. There's not one onion file per version. So it's not that you do 3 different opens and you get 3 different onion files. It's just much of the point of it was we had to decide where to put the new version information. And I think the people who are funding the initial implementation of it wanted to leave the original file completely alone and just not touch it. And so, because there were talks of putting it, just appending it to the file and changing some stuff with the user block, but so it could be in the same file, but we just initially implemented in that way. But it's one single onion file that has all the other versions in it. So
And then also related to that, I remember a few years ago, I thought that there was going to be an option of creating like a mirrored file. You could, while you're writing a file, another file is also written, which is a copy. But
Right, the splitter or mirror, yeah, I forgot what we called it, where you write or you create a local copy and then over a socket you can write to a remote host. Is that what you mean?
yeah, I think so. Is this
That's in the library. That's in at least one. There's at least in 113 and 112, and maybe I think it's also 110.
Yeah, mirror VFD.
Okay, I must look at that.
Yeah, but I think to your earlier question, I think what you can certainly do is, yes, there is only one onion file, but let's say you want to implement Git-style versioning. You can, of course, once everything is closed, you can create a copy of that onion file and sell that to another process that wants to keep that view, and then the onion, you can create other onion files. So if you then maintain sort of versions of onion files, so to speak, on your own, you can implement any kind of branching that you want.
But okay, that we'll look at that. But the onion file doesn't help. Does it help against file corruption? No. I mean, if you
not really, no. It just changes. I mean, everything that's implemented in the onion file is essentially HDF5 stuff, right? The same object headers and things. But there's some new stuff that deals with onion bits for like the index and stuff like that. But it doesn't really change the problem very much. It spreads the problem across two files.
Mm-hmm. And does onion, I mean, onion is pass-through, right? So could I stack onion on top of VFD Swimmer?
I don't think we've ever tried that.
But that would be an interesting test, because with the sort of better guarantees regarding corruption that you get with Swimmer, if you could put onion on top of that, I mean, theoretically it should work. It's probably untested, but it should work. I mean,
but they're not in the same branch, so we couldn't test
them. They are not in the
yeah.
same branch at the moment, but it would be an interesting test to do.
In July we could.
Yeah. Okay. Other questions? Yeah. Right.
Yeah.
That's right. Yeah, that's true too.
Yeah, for old Swimmer,
yeah.
Maybe, right? I don't know if we have, because there's a support Swimmer VFD flag, and that may not be in the Onion VFD.
Mm-hmm.
I don't know. It's not been tested, so.
Okay. Any other questions? No? Then maybe part 2.